why is it that we have problems with barriers, particularly doors and penetrations? They were constantly in the top 10 violations at the Joint Commissions during the Joint Commission's audits of healthcare facilities around the country and around the world, because the Joint Commission gets over to the Middle East and they get to other places as well. Why is it that we have problems with barriers? So 3 years worth of this at the ASHE annual convention, where 2,500 people are sitting at the plenary session, plenary meaning all members of ASHE that are in attendance at the annual conference. 2,500 people, a great big stage. George Mills is constantly asking, why are there problems with barriers? The American Society for Healthcare Engineering, the association for the individual facility manager people, said back to the Joint Commission, hey guys, we need you to be part of the solution. We need to come up with some kind of an education program to help educate the facility engineer about barriers so that these violations drop. So Dale Wooden, the executive director of the American Society for Healthcare Engineering, George Mills and I, and the Joint Commission staff, and Guglielmo, John Maher, and others sat down and assembled this barrier management symposium. The pieces of this symposium, several of them, were already being delivered to the International Code Council's chapters in various parts of the country. We had a program called the Total Fire Containment System Symposium. We've done it in Dubai, we've done it in California, Chicago, Colorado, as well as other places. So to customize this for the facility engineer, we added several pieces to it, and we'll get into that here shortly. The Barrier Management Symposium is a 2-day program. And what we did was added Jonathan Flannery, ASHE's Senior Director of Advocacy. Ann Guglielmo speaks on behalf of the Joint Commission and what they look for. Rich Walke from Underwriters Laboratories, a well-known person in the fire resistance industry because he spent his whole 30-some-odd year career in it, from Underwriters Laboratories, covers the testing. Bill Koffel actually speaks before him and covers barriers. What are the types of barriers that are described in the International Building Code, from fire wall to fire barrier to fire partition to smoke barrier to smoke partition to exterior walls, and how are they used and referenced in the code. Nestor Sanchez speaks on behalf of the gypsum industry from USG and always brings a great sense of humor to it. Rich Walke covers some of the testing for concrete. I cover the fire stopping industry. Paul Balargian covers the swinging door industry from the Door and Hardware Institute's Door Safety and Security Foundation. Mark Sorgi speaks on behalf of GreenHeck for fire and smoke dampers, and then Tim Warren and others speak on behalf of the fire-rated glazing industry to cover fire-rated glazing. What we try to do during this program is cover the DIIM for all of these pieces, not just for fire stopping, but take the other industries and look at how they find ways to get proper design, installation, inspection, and maintenance. And we can see, based on some of the programs, that each of the industries is a bit different. The fire stopping industry has decided they're going to build standards for each of those programs, the DIIM. Standards, ASTM E814, UL 1479, UL 2079, ASTM E1966, and ASTM E2307. These are all test standards for fire resistance rated fire stopping in specific applications. The other industries have the same thing. The fire doors, UL 10, A, B, and C. Dampers, UL 555 and 555S. The fire-rated glazing in the walls are tested to ASTM E119 or UL 263. So all of these have in common tested and listed systems. Or in the case of concrete, as well as existing buildings where there's archaic structures or archaic assemblies, they call it, there are other methods for determining suitability for use of those products in specific applications. For instance, an old clay tile block wall may have fire resistance rating. If we were to go into the UL directory, FM directory, or Intertech directory, we'd never find that assembly. So in the back of the International Building Codes, Chapter 7, you'll find in the section assemblies. So if the beginning of the building code, chapter 7, it says fire resistance is determined by tests, methods based on tests, or this code. When it says this code, it's talking about the very back end of the International Building Code. Depending on the version, could be 720, could say 722, where it determines what the thickness is for equivalent thickness of fire resistance ratings. It may say that concrete with an aggregate of X and a thickness of 2, 3, 4 inches results in a 2-hour rated assembly. It also sets up in that area the need for engineering judgments as well. But the key thing is that there's tests for design. Installation is where things get different. The FCIA worked with FM approvals and UL to come up with the UL Qualified Contractor Program, the FCI or the FM 4991 program. Under the rest of the programs, you really won't find anything as far as the installation, other than fire and smoke dampers, where the Sheet Metal Workers Union formed an organization to accredit those sheet metal contractor organizations that are signatory to the Sheet Metal Workers Union. So you have to be a union contractor in order to get that designation. Other industries have focused on inspection. For instance, the Door Hardware Institute went to NFPA 80, and they worked at having requirements for inspection of fire doors throughout their life cycle. As a result, they came up with the Fire Door Assembly Inspector Program. There are other programs, but the DHI has probably the most extensive program for handling that discipline. Fire-rated walls, fire-rated glazing, there are no real requirements for installation and inspection. Although in maintenance, there's a common section in the codes that deals with it, which we'll get to along the way. So, Jonathan Flannery at our FCIA Joint Commission, UL, and ASHE Barrier Management Symposiums asked the question, why are we educating with the Joint Commission? Typically, ASHE, the healthcare organization, isn't educated by the accreditor, because that tends to blur the line of objectivity between the accreditor and the accreditee. There needs to be some separation in the accreditation world in order to say that the accreditor isn't teaching to the test, if you will. But in this case, ASHE and the Joint Commission identified a problem. Both of them have a passion for patient safety, as do all of the members of the FCIA. A passion for patient safety, and a trusted industry resource. So with ASHE's mission being dedicated to optimizing the healthcare physical environment, these programs then took off. They were announced several years ago at the ASHE convention, where the Joint Commission handed out brochures on the barrier management symposiums. We've done 5 of these 2-day symposiums in various locations. We did it in Steamboat Springs, Colorado, to 175 people. Philadelphia, almost over 200, almost 300. Rochester, Minnesota, 100 plus. Indianapolis, about 100. And there's 5 more of them planned for regions in the next 13 months. Additionally, ASHE is assembling a 1-day symposium for chapters that you'll see more about as announcements come up and dates get firmed up. Program developers, the Joint Commission, the Firestop Contractors International Association, I do all of the recruiting of the speakers on behalf of FCIA and organize the speakers and get them there. The ASHE organization works together to bring in the ASHE chapters and builds the program itself. The objective is to share knowledge, build barriers for safety that are properly designed, installed, inspected, and maintained. We talked about that already, so I'm not going to get into the details, but the DIIM philosophy is something that FCIA's worked with from the very beginning of our association. That's why we have an FM 4991 program and a UL Qualified Contractor program. That's why we have the Manual of Practice. Good associations should develop a body of knowledge from which the industry can train from. There ought to be installation companies that are equally capable as the manufacturers who have invested millions of dollars in testing and product development. Those manufacturers have ISO 9000 programs for quality management. Why doesn't the contractor have a similar program? That's why the FM and UL programs exist. What about inspection? Any good manufacturing process has a check and a balance to make sure that the output works. And if the output is incorrect, the input, meaning the installation, has to be corrected through quality management. FCIA's FM 4991 program and UL qualification for the contractor company works on that premise along with the inspection. The maintenance and NFPA 101 and NFPA 5000 both have programs on it. Barrier management program is based on total fire protection. The association believes in all of these things. Education and egress programs are as important as effective compartmentation. The effective compartmentation and fire resistance, when looking back at history, is actually the first line of defense that has come for buildings starting many, many, many years ago. Compartments were built in buildings to contain fire spread so it doesn't move from place to place. It's used on ships, submarines, and other structures to prevent fire spread, water spread, smoke, and other elements as well. But fire resistance is the first fire protection feature that was invented. Sprinklers and alarms came later. Education of occupants has gotten even better over the years. Watch for more programs on that from FCIA as time moves on here. Before we have fire resistance, fire stopping, and fire resistance rated assemblies that contain dampers, ducts, etc., we have to have fire resistance rated assembly. That fire resistance rating has to be continuous. That's what sets up the need for fire stopping, fire dampers, fire rated doors and hardware, whether they're rolling or swinging doors, and fire rated glazing. Continuity is critical. Interestingly, if you look at the far left construction, there's a violation there if you want to be, as we look at it. Certainly the wall seems to have been constructed very much to a UL design. Below the ceiling tile, the screw heads are all treated with gypsum compound. There's tape and drywall compound over the top of the joints, which are running vertically, occurring at a stud. Hopefully on the other side of the wall, the joints of the wall board are offset. The violation is that in order to have continuity, that fire resistance rated wall should be going up to the roof deck above, which would be the termination point of the fire resistance rated assembly. Instead, somebody put a steel beam running across the top of the wall, which has no structural steel fireproofing on it. So therefore, the continuity of the wall actually stops at the beam rather than at the head of the wall. Secondly, there's no fire stopping at the top of the wall as well. But fire dampers, fire stopping, fire rated doors, and fire rated glazing all provide fire resistance. These things become systems. FCIA at the International Code Council development process in the 2006 cycle added for the 2007 supplement in Chapter 7 that the fire resistance is a system. It didn't exist in Chapter 7 at the beginning of the International Building Code before that. So these products become systems through their testing. I've laid out the test standards that are used, and that testing sets up a suitability for use statement for the specific product in the system application. If I were to go to the UL directory, I'll find systems that describe what to do with fire-rated glazing. And those systems deal with very complex and limited applications. See if I can get this out of here. There we go. So to go find these systems, I'm going to scroll down to the online certification directory. It's going to take me to this screen automatically. Thank you very much. And I'm going to look for fire resistance rated assemblies. For fun, let's see if I can find the fire door and window assemblies. And I'm going to search for technical glass products. and it's going to give me some systems. It's going to give me the general information. So if I want to go to the systems, I'd have to go to the other assembly. But what's going to happen is it's going to tell me what the frame should be made out of, what the door is made out of, what any glazing is made out of, and how that interacts with the wall and floor. The one thing that's common amongst all the fire resistance, whether it's fire-rated glazing, the damper, the door, both swinging and rolling, and the fire stopping, is all of them have the hose stream test. The hose stream test is a shock test to see if the application of force can push whatever it is out of the assembly. Push the fire door out, push the fire damper, or expose holes in those applications. So that hose stream test is common across all lines, including fire stopping, fire doors, fire-rated glazing, and the fire and smoke barrier, the gypsum or concrete block wall that it's made out of. So that hose stream test is all the way across the board. The results are fire resistance directory is where you find the tested and listed systems, whether it's Intertech, FM approvals, or the UL directory. They will all have detailed information about how the wall is constructed, how the frame for the door is tied in, how the damper is installed, et cetera, et cetera. Each of these will have different unique things to them. For instance, the fire and smoke dampers have a drop test in addition to the hose stream test. The drop test is actually a 55-gallon drum with sand in it weighing a certain weight that's lifted up 10 feet, 15 feet above the assembly and then dropped over the duct to make sure that the damper stays in the opening and that the breakaway connections between the ductwork, which supplies the air, and the damper, which provides fire resistance, that those two things separate and that the duct would fall to the floor. In fire-rated glazing, there are impact tests where bags of steel balls would be dropped from a certain height to see if it could punch a hole through the assembly before it has a fire test, in addition to the hose stream test. In fire stopping, you don't have that. It's simply the hose stream test that is used for impact as well. Question came up, will these slides be available? Yes, we'll put them up on fcia.org, right-hand side, under Hot News. I should have it up there by later tonight. So the hose stream test is common. The fire resistance directory is common for all of the different applications. And these systems have to be installed. When it comes to contractors, the FM 4991 program is a management system-based program. Same thing with the UL Qualified Firestop Contractor program. It has 10 different subsections that have to have policies and procedures written around it. Employee training, system selection, record keeping, communication of systems and documentation to the field and back from the field into the project file. Documentation, how long does the company keep that documentation? Documentation that's kept are the life safety drawings, specifications, tested and listed systems, and then the manufacturer's installation instructions. All of those pieces are kept in files. For how long? Under the UL and FM programs, 7 years they have to be kept. So there's got to be a management system around the company's operations that explains all these things. Currently, the Firestop industry is the only industry, other than structural steel fireproofing, that have embraced the management system-based program. Most other programs are individual certifications where an individual takes an exam of some kind after a little bit of training, 10 hours, 16 hours, 12 hours, whatever it is, and then they're declared, quote, certified. This is just about the company and the individual, the FM and UL programs. And the idea is understanding the systems, their communications, and how they get installed. Why should there be contractor qualifications? Really, it's about accountability and building the building right the first time. The healthcare engineer, the university, the office building, the building owner and manager lives with that building after it's been built. And if the general contractor was not educated enough to know what a quality application looks like and what it doesn't look like, that building owner, by mistake, could get stuck with a building that has not a single fire resistance rated assembly in it because there's violations in fire stopping, fire doors, and fire dampers. As an industry, the reason for this barrier management symposium is to educate not just the ASHE facility manager, but everybody in our industry as much as we can about fire resistance, how it's built, and the fact that it's a system, that there's certain tolerances that have to be kept, annular space sizes, angles around the fire damper that are continuous and not broken by gaps, gap sizes, whether they're undercuts for doors that are compliant with code requirements and an FPA 80, framing that's tied into the walls appropriately as the tested and listed system shows. And in some cases, in the case of fire-rated glazing, even fire stopping in certain applications where it's specified. If you look at the tested and listed systems for fire-rated glazing, it'll show for some tested and listed systems, enclosures, activation sensors, and more, so that the circle of quality works. Whether it's the design, tested system, the installation, the qualified contractor, and the other two pieces, which we're going to talk about next, the inspection and maintenance, all of these things need to go around in a circle continuously for that building to be safe when fire comes and these fire resistance rated systems are called upon. Installation and inspection go around in a circle. There's really three types of inspection that can take place. Under the FM and UL qualified contractor programs, there's contractor self-inspection that the management system actually works. Contractors have their crews double back and take a look either hourly, twice a day, once a week, whatever the company thinks that works for it to maintain its management system quality, whatever that frequency is, that's what the company does. But all of them have to verify their management system validity through some kind of inspection of their own work by their own people. This is different from a special inspection or a third-party independent inspection. Manufacturers in the Firestop industry and most of the fire resistance industry don't really inspect. Why? It's different than the roofing industry, where they do not have a 10-year labor and material guarantee or warranty that's given to the building owner verifying that the product will be installed to the specifications and work. In those instances, the manufacturers have a pretty big liability. Liability is the roof is going to leak and they have to replace the whole thing and wind up with an upset customer. In the fire resistance industry, there is no labor and material warranty accepted in the, or not accepted, that's offered by major manufacturers of Firestop products. So therefore, the inspection doesn't take place because there's no reason for it by the manufacturer. They support, as do we, the FCIA, so the manufacturers of fire stopping support special inspection and a good contractor. When you have both, the price to the building owner manager is correct. Price meaning the installed cost, the actual installed cost of the system after it's been installed and given over to the owner. It's done right the first time. It's been verified by a third party either through destructive testing or non-destructive testing at a specified frequency by a special inspector that has competency to inspect the type and complexity of work that's being inspected, and by an inspection agency, a company, whether it's a sole proprietor, sub-S, LLC, or a C corporation, doesn't matter, but that agency, inspection agency, we hope has the qualifications to inspect fire stopping and other things. There's already a program that exists, International Accreditation Services. I sit on the board of directors of that organization. Has a program named AC291. That AC291 program is a management system-based program like the FM 4991 and the UL Qualified Contractor Program, but it's focused at special inspection. So 3 different types of inspection. All of them exist to try to build safety and fire resistance. But maintenance and management is critical. Let's go back to inspection just for a second. I'm going to spend a little bit more time there because I think it's important that we do this for a couple of reasons. First one is, in the International Building Code for new construction, special inspection is now part of fire stopping. The FCIA, at its 2000 meeting, had Mike Pfeiffer, Vice President of Codes for the International Code Council, come and speak to us. A question was asked by Roger McKenzie and Don Sabrasula, a couple of contractors, one from Atlanta and one from Houston, and they said, hey man, how come we don't have inspection for fire stops like we have inspection for fireproofing, structural steel fireproofing? Special inspection for fireproofing has been in the codes for a long, long time, and has been there for decades, I want to say. And Mike Pfeiffer shot back very quickly, well, do you have a standard? The answer was no. So Mike then said two things. First one is, go make a standard at ASTM, which we did after we formed a standards committee and worked together with our manufacturer partners, some who are members of the International Firestop Council, the Manufacturers Association. We worked together with them to develop a standard for inspection. We then went to the code. FCIA paid Bill Koffel, our code consultant, and I, of course I work for the FCIA, to go at the code hearings and put it in as a requirement. It took us 3 code cycles, so 10 years to get this done. So Mike Pfeiffer's second thing that he shot back was, this is your code. You submit your code proposal to change it, and if you're successful, you'll have special inspection. As a result, here's what we have. The building code official can put together policies and procedures in compliance with the intent of the code and not waive stuff. Inspections can be done by the building official, or they can accept reports of approved agencies. The approved agencies have a definition as well. Fire stopping is one of those things that has to be inspected before it's concealed. In 110.3.6 of the International Building Code, it says, protection of joints and penetrations shall not be concealed until inspected and approved. What we found as an industry is that the building official fire marshals don't have the staff to inspect all the different times that it might be concealed. If you can think of a high-rise building, there are many different phases. That means that the building inspector from the jurisdiction would have to come to the building site and approve every time they close up a wall. Realistically, the building official doesn't have the responsibility for quality control for the building, and this is a bit much for them to do. The building official can also accept reports of inspection agencies, provided that it satisfies requirements. The agency is a defined term in the code. Approved agency is established and recognized agency. Now, agency can be a corporation, like I said, 4 different types: sole proprietor, sub-S, C corporation, LLC corporation. Regularly engaged in furnishing tests, inspections, and conducting tests. The approved is also a defined term. The approved is acceptable to the building official. There's also a definition for the special inspector. That's the individual, qualified person employed or retained by. So it could be an independent contractor working for an agency or an employee that's also approved by the building official, having competency necessary to inspect a particular type of construction requiring special inspection. This is pretty clear. It says competency, particular type of construction. So if they're inspecting fire stopping, they're going to be competent in fire stop. In Special Inspections, Chapter 17, it also goes on to say that the approved agency has to provide information. The approved agency has to be independent, objective, competent, independent from the contractor installing the work. And the personnel shall be experienced in conducting, supervising, evaluating tests. Alternatively, the owner can have the registered design professional as their special inspector as well. And then it goes on to talk about special inspector qualifications, and it's 2 paragraphs that the special inspector has to provide. Experience or training, here it goes and says complexity, same type of special inspection. So a welding certification doesn't help you in accepting whether or not the inspector can inspect fire stops. And then here's what the standards say about penetrations and joints. High-rise buildings, that's a defined term in the building code. That means 75 feet and higher above lowest fire department access, and the 75 feet is the highest occupied floor. So it's not 75 feet to the roof, it's 75 feet to the highest occupied floor. Contrast that to the NFPA, and that says 75-foot high building. National Building Code of Canada, I believe, does the same as that as well. So special inspection can also be prescribed for unusual design applications, engineering judgments, that kind of thing. High-rise building we talked about. And then penetration fire stops are inspected to ASTM E2174 and 2393. Those standards have also got independence in them as well. Critical thing to remember, though, is that the ASTM inspection standards say that the notification of variances to the contractor is 1 day after they're discovered. The International Building Code says that the contractor must be notified immediately after the discovery takes place. That's a huge difference between the two pieces. Now, it doesn't mean it can't take place, because with cell phones and text messages, if it's set up right, the contractor can be notified immediately. Especially, this is especially true in the situation of 2% destructive testing or 10% variance. Let's take a look a little bit more about the standards. The inspection standards, all ASTM E2174 says is that you need 2 years experience and accredited to the AHJ. If you remember, the code says that the inspector needs to have experience in the same type of inspection and the type and complexity of the materials being inspected. So the code says that the inspector should be experienced in fire stopping, looking at that language. The standard, ASTM 2174-2393, currently doesn't say you have to have any experience in fire stopping. It just says experience in construction or field inspection and accredited by the AHJ. One thing that can change that from a specification perspective, if you're a specifier in the line, you can stick in your specification under the general requirement references the IAS AC291 program. That AC291, if it's a requirement in the execution section of the specification, Part 3, where third-party independent inspection hired by the owner, not by the general contractor, takes place, you could drop the AC291 requirement by an AC291 accredited company. Once that happens, then at least one person has passed the FM or UL Firestop exam and has the same knowledge as the contractor. That's important, because if there's a balance missing where the contractor is smarter than the inspector about the fire stop industry and what needs to take place, then you wind up with a contractor that may be able to pull fleece over the eyes of the inspector. That's not really what we want as a contractor organization. Kind of crazy to hear a contractor organization say we want good inspection, but really it's in the interest of fire and life safety and in good construction, which we're after, because as an industry, if we provide the building owner and manager the right stuff, first time, every time, on time, right quality, then our industry looks better across the way. If we've chosen to invest our careers in it, why shouldn't it? So there's a pre-construction meeting in the 2174. There's mock-ups that are put together. Destructive testing is done, and the inspection method is discussed. The inspection method for inspection of fire stopping is 10% of each type of fire stop, no less than 1, or 5% of the total lineal feet of fire resistance rated joint system. This is the over-the-shoulder inspection. So there's two methods allowed under 2174-2393, either over-the-shoulder as the contractor is installing, or destructive testing. The destructive testing is minimum 2%, no less than 1 of each type of fire stop per 10,000 square feet of floor area. Minimum 1 for every 500 lineal feet of joint area as well. This standard, the 2174-2393, is referenced in the appendix of the National Building Code of Canada. It's also in the appendix of NFPA 1 and NFPA 101. The FCIA, the International Firestop Council, worked together to put that in the NFPA code. The International Firestop Council, the Manufacturers Association, supported the FCIA during the International Building Code development process to have this put into the code. So, again, when there's variances, one-day notice to the contractor under the standard, and under the code, immediate attention. In the code world, once you look at building code, the building code language always wins over the standard that's referenced in it if it's more restrictive. Therefore, on projects where the International Building Code 2174-2393 are mandated, this language is required. If there's variances, the inspection stops. The inspector notifies the contractor through the proper channels. The contractor corrects their work, and then back they go. There's an inspection report that has forms. There's minimum requirements in the inspection standards about those forms, and they're submitted pretty quickly as well. The code then talks about the inspection report, and here's what it says: the immediate attention of the contractor for correction. That's huge. It's sitting right in the building code. So it's important to have those things. Got a question that just came up on inspection. It says some of the projects we are working on, the third-party inspector is requiring that the Firestop systems on the project be included on the drawings. Is this part of the inspection code or the inspector's prerogative? Great question. The International Building Code doesn't necessarily say what systems need to be referenced on the drawings. What it says is that the fire-rated barriers have to be located and marked on the drawings. And typically what happens with the architects is they'll put a representative sample of what systems might be on the project itself, but not necessarily tying it to every single system, because we know that the electrician has not decided what size and type of conduit to use or cabling to use. And in many cases, the mechanical plumbing contractor may not have chosen the type of penetrating items that are going to be used on that project. So therefore, it can't be 100% of the tested listed systems on the drawings. There will be post-submittals done, a deferred submittal, if you will, for fire stopping. Great question. Thanks for asking that. Moving back to the slides, the FCIA believes in inspection. We believe in quality contractors. We believe that you need both the installation and inspection properly done to have the right value delivered to the customer, the building owner and manager that uses the building after it's all said and done. We believe the individuals should be educated and trained. We really respect the manufacturers for all the work that they have done over many years to educate building code officials, contractor personnel, inspector personnel. The FCIA has done the same thing as well, and we've worked together as an industry, sometimes separately, but all after the same result. The right stuff installed the right way, inspected appropriately, maintained for the life cycle, so at the end of the day, when a fire hits it, it works. Both associations, both organizations are after the same thing. Under the specification side of things, we talked a little bit about it. Now, I'm going to cover this just quickly for a couple of minutes, because while most of our industry focuses on the building code and the fire code, specifications are huge too, because it sets up the scope of work. Before I get there, I've had a question come in about destructive testing. Let me back up a second, back to the type of inspections. So there's two types of inspections under the ASTM E2174-2393. The first one is, as the contractor is installing the fire stops, the special inspector, using a measuring device equal to the measuring device of the contractor, so both of them are using tape measures, which under the quality management system approach from UL and FM, these measuring devices have to be checked to make sure that they're legible, to make sure that the markings are appropriate, to make sure that they're not bent to the point that the measurement is inaccurate. If you look at this tape measure, there's a little bit of a bend in it. Is that going to affect things? I'm not too sure. We'd have to ask UL that. At one point, UL was going to put into their qualified contractor program that the measuring tape had to be calibrated. Calibrated measuring tape is $150. We then asked UL, how do you measure your inner spaces in the testing laboratory? And they said, we use measuring tapes. We asked the question, are they calibrated? They said no. Therefore, we said, in order to pass through exactly as the lab tests it, we're not using calibrated measuring tapes. So therefore, random witness is one thing, and then destructive testing is also done. So the destructive test would be, we would take the tested and listed system from the UL directory for this particular opening. It looks like a cable tray going through a fire resistance rated wall with an annular space of X and a number of cables of X, and check all the parameters. Is the annular space match up? Do the penetrating items match up? And does the Firestop system product that was installed match the system that's shown in the directory? If it's supposed to have a ½ inch of latex-based intumescent Firestop sealant, if we're inspecting right away as it's being installed, is it a ½ inch deep? If the product has been there for a month and a half and has experienced some shrinkage, as all latex products and all Firestop products that cure, that are not two-part catalyst cured, have they shrunk and how much? And does that shrinkage match up to the shrinkage reported by the manufacturer of the Firestop product to determine whether or not we got the appropriate thickness? So destructive testing is cut open the seal, check the components of the Firestop, and see that they match up to the tested and listed system. Is the direction of the penetrating item match? Does the wall or floor match up? All of the different things. So thanks for that question. Glad you asked it. Back to the program. What about specifications? In part one, you're going to want the products listed, or the references, ASTM E2174-2393, ASTM E814, UL 1479. That's all in part one. In part two, you're going to describe some of the testing that needs to take place that qualifies those products for use. Under part three, quality assurance, that's where you're going to have the independent inspection. It needs to reference back to Division 1 so that it's hired by the building owner and manager and not by the general contractor. Why? Because if the general contractor is hiring, they're responsible for the schedule, and it puts a conflict between the inspection and the schedule. The schedule has to roll. The inspection may slow it down. And then the references, you can take a look at these at your leisure along the way as well. One question that constantly comes up is, you know, our facility has standardized on pick a manufacturer, STI, Hilti, 3M, Rector Seal, any of them. They're great manufacturers. We support them all, and they're good friends. But can we have a single product in that application? It gets difficult when the engineering judgments start showing up and whether they're accepted or not. The rule of thumb for engineering judgments is that if there's a manufacturer that has a tested and listed system and it's not the manufacturer of choice at that facility, we're supposed to use the manufacturer that has the tested system. That means we're switching manufacturer. Therefore, as a specifier, you can use a single source product to the greatest extent possible. That greatest extent possible opens up the possibility that we can switch a manufacturer. In other words, we're using as much as we can to the single source, but if we have to use another manufacturer because they have a system and one of the other guys doesn't, then that sets up the ability to do that. Where does that come from? The International Firestop Council, which is the Manufacturers Association, has a protocol for engineering judgments. And that protocol is pretty specific. It talks about the manufacturer producing a engineering judgment and others accepting it. One thing that you want to do is make sure that whoever manufacturer is being used, that the engineering judgment, it being written on there by the manufacturer, that they believe it'll pass a fire test. That way they're making the suitability for use statement for the product. They know the fire test capabilities of these products. You and I and the many others on this call didn't stand by the fire test to know where the boundaries are. Only the manufacturer did that. The manufacturer's technical personnel are the people that know what those requirements are. Under the systems, FT, H, L, and W ratings are all important. L ratings are particularly important in smoke barriers, which we'll find in hospital organizations, which is where we find barrier management programs. Smoke resistance, our industry, the Firestop industry, has declared that smoke resistance is gained through L-rated Firestop systems. So the question that frequently comes up, okay, we've got a smoke partition, which is not a fire-rated assembly, but it wants smoke resistance. What do I do? Well, think about it. The wall is made out of 5/8-inch gypsum wallboard. That 5/8-inch wallboard, regardless of whose it is type X, whether it's fire-rated or not. It's installed on metal studs or wood studs, spaced appropriately to hold the wall up. That spacing likely is the same as you would have with that fire-rated assembly. It has screws that hold the wallboard to the studs, and it's continuous to the next assembly. The only thing that changes is it's not been declared a rated assembly, but it looks just like, tastes just like a fire resistance rated wallboard assembly. So therefore, we believe that installing a Firestop product that is L-rated into that assembly gives the closest approximation for smoke resistance that we have. It gives a quantified smoke resistance, which is required for smoke barriers, not necessarily required for smoke partitions, but it is the suitability for use statement of Firestop products as smoke resistant assemblies. And in a court of law, if someone's going to be dragged in, the facility manager is going to be asked, what did you use for those smoke penetrations? Well, I used a smoke seal. Okay, what's that? Well, we went out and bought a bunch of acoustical sealant and put it up there. Figured if it worked for sound, it'd probably work for smoke. And then the lawyer is going to ask, is that hot smoke or cold smoke? And we're going to say, well, we don't know. Well, what do you mean you don't know? There's a test standard, L ratings. Are you aware of it? Well, yeah, we will, but that was more expensive. Well, then if somebody died or some damage got hurt, why did you allow a cheaper system for that? So very important to really follow what the industry's done. The L-rated Firestop is the suitability for use statement for Firestop product, and it alone has a smoke rating along with a system as close as you can get it to the tested and listed system that you'd find for Firestops. W ratings is for water resistance. Why do I put floors? Well, compartmentation as a concept is used below grade. Let's say there's Firestops that are located several inches or several millimeters above the floor assembly and you're in a basement. Guess what? It could flood. A W rating would help protect that next compartment from water flow into the other area. As far as maintenance and management goes, let's go back to the other presentation and talk about barrier management. Maintenance is critical, and I'm not sure maintenance is the right word. I think management, barrier management, is a better word. Why? When we talked with the Joint Commission and the American Society for Healthcare Engineers about this barrier management symposium, at first the discussion was about these holes in the walls and these darn doors. The doors the fire doors don't close and latch. They're propped open, and they're not paid attention to. And what about those holes in the walls? Well, yeah, it's about that. But what about the angles on the fire dampers? Were they put in right? What about testing them as required by the fire codes and NFPA 80, which is testing it upon commissioning, testing it upon 1 year after it's been commissioned, and then every 3 years in office buildings and every 6 years in healthcare facilities? What about that? Is that done? What about the fire-rated glazing? Has the wall been compromised between the frame and the wall that would cause it to fail the hose stream test? And what about the rolling doors and the fire stops and the wall itself? How has the wall been repaired to make sure that the fire resistance is held? Can we just put a bunch of drywall mud over that hole and still have a fire resistance rated assembly? Can we just put a bunch of grout or mortar around it and still have a fire rated assembly? So very quickly during the discussions, we decided, the Joint Commission decided, American Society for Healthcare Engineers, FCIA, and UL thought we should be talking about the whole barrier so that it's bought as a system. Because it is a system, each component needs to work right for it to protect people at the end of the day. If we as the fire stop industry do a good job, but the fire damper doesn't work, we've still got a big hole in the wall. It's going to cause issues. So therefore, this barrier management program focused not just on the after birth, if you will, after the building is born, but the life cycle of the building. And the knowledge that you need to know in order to maintain a structure, to buy the services to maintain and manage it, are the same regardless of whether you're buying a structure new or maintaining its integrity throughout the life cycle of the building. So we talk about maintenance and management. That's what this barrier management initiative is. How do we track it through the life cycle of the building to make sure that the building has fire resistance rated assemblies throughout its life cycle? First thing is that the building and fire codes require it. NFPA 101, the Joint Commission of Forces, NFPA 101-2000. But if you look at the language in the 2000 version of the code, as well as the 2012 language of the code, they're basically the same. In NFPA 101, which is what healthcare facilities operate under, and a lot of other accredited facilities, day surgery centers, on and on and on. It says wherever and whenever a device, system, fire-resistant construction is required for compliance, the device has to be continuously maintained in accordance with NFPA requirements. That's the ASTM E814 tested system for fire stops, UL 555 for the damper, on and on and on. So continuous maintenance. Now, in a court of law, question would come up, well, what's continuous maintenance? Certainly, no building owner is going to check above ceiling tiles to make sure that there's continuity of fire resistance every day. That's unreasonable. But what's a reasonable time frame? We'll talk about that in a little bit, because I think other codes have already laid that out. Also under NFPA 101, it talks about no life safety feature shall be removed or replaced if it's obvious to the public and not required by code. It still has to be maintained, so that means the building owner manager has to remove stuff if it's been declared not required by code. So if the compartment got bigger and that fire rated barrier is now declared not rated, if the building owner or manager wants to not maintain it, they have to remove the fire resistance rated stuff. Probably because the public thinks that because it's got a fire door with a label on it or with a fire rated hardware with a label on it, then it's fire resistance rated. They may think that it's fire rated and therefore look for protection behind it when they might not get it. And then under 4.5.8.5, the very bottom of it, talks about maintenance, inspection, and testing shall be performed under the supervision of a responsible person that ensures that it's done at specified intervals. So supervision of a responsible person, that means the building owner manager has to appoint some kind of a responsible person, and it's got to be done at specified intervals. The interval for the inspection has been laid out by the International Fire Code. This 703.1 section, and this is a simplified section out of the 12 code. The 15 code has even more sections on it. And it talks about the fact that fire resistance ratings, smoke barriers, fire barriers, structural steel fireproofing, et cetera, has to be maintained, and that the elements shall be visually inspected by the owner annually. So there's your court case out, if you will, as a building owner manager. If you have in your procedures that you visually inspect the barriers annually, you've probably covered yourself. But if you think about it, where it says shall be maintained, That's a continuous rating, the first paragraph or the first sentence, if you will. And that ties back to the continuousness required by the NFPA 101. How do you cover that in your procedures as a building owner and manager? Best thing to do is to have some kind of a barrier management initiative in your facility. What that means is that any contract that's let to an electrician, a plumber, a cable guy, a wallboard installer, a concrete block installer, that comes across a barrier, that there be a procedure for handling that barrier. Maybe the building owner manager's procedure is that when any trade sees a barrier, they simply notify the building owner manager, the ASHE facility engineer, that they're at a barrier and that they need a tested and listed system to restore that barrier to the rating it was before the penetration or opening or joint came to it, and that others would perform that work. Some facility managers want the trade that's penetrating the wall to install the right system in that application. Others have hired a barrier management contractor to go around and make sure that the assemblies are installed properly and restored properly during the life cycle of the building on an annual basis, on a monthly basis, or on a quarterly basis. Whatever that facility decides, that would has to be done. So, how do you maintain the fire ratings? Visually, by the owner, and then continuous with some kind of procedure. I've had a question come up that says, what about a product that is called smoke and sound for smoke walls? That's pretty much an acoustical sealant. Well, thanks for the question. I don't know what that smoke and sound stuff is. The question would be, has it been tested, and does it have an L rating? The L rating is the suitability for use statement for Firestop products and specific applications. If it has no L rating, then it's not a smoke system. So those are the questions to ask. Thank you for asking that. Going to the Middle East, the UAE Fire and Life Safety Code of Practice, of which several members that are on the phone worked on, has similar language to the International Fire Code. Visual inspection annually, and then protect with approved Firestop systems to comply with applicable codes as per the guidelines of the civil defense. In the Middle East, the United Arab Emirates, the civil defense is the same as the building official, fire official type person. In the National Fire Code of Canada, it talks about damage to fire separations, where they're damaged so as to infect the integrity. They shall be repaired so that the integrity of the fire separation is maintained. So again, it gets back to the continuous and the maintained. How frequent does that maintenance have to be taken place by the building owner manager, and then what do they do? The FCIE Manual of Practice has a complete appendix on maintenance and also recommends barrier management. So now you're the building owner and manager, and you got to say, okay, this is a real pain. I got the plumber, the mechanical, the electrical, the drywall person. I got people punching holes through these fire-rated barriers like there's no tomorrow. How do I deal with all these problems that are coming at me at once? Well, the old management adage is, don't fight the alligators. Drain the swamp of the water and it'll kill the alligators. The barrier management program is, regardless of which one you use, is there for that reason, to fight the root cause of the problem, which is how do we manage the barrier, and then work backwards to kill the alligators. The barrier management begins when new construction ends. In new buildings, the specifications are very clear. The specifiers we've spoken to since 2000 and before, and had great discussions about specifications and what to do and how to line them up. Master format has evolved over the last several years such that the 078400 section for fire stopping already exists, and it does a great job. What we really need to do is take a look at some of the other fire resistance rated construction specifications. Wallboard somewhere else, fire dampers are somewhere else, and find a way to reference those systems in one specific section. That's another initiative for another day. The common element, though, regardless of whether there's dampers, doors, etc., that these are all systems with systems expectations, tested test standards for those systems, and documentation built around those systems. So now it's the building owner's program to deal with. And there's lots of things that need to be maintained. The wall, the doors, the dampers, the joint systems at the head of wall, hot and water cold piping, hot and cold water piping, laboratory waste, could be plastic, polypropylene type piping, could be glass piping, pneumatic tubing, sprinkler piping, rigid electrical conduits, could be non-rigid electrical conduits. And these are all going to have tested listed systems, as you can see down below, that outline the type of penetrating item, the annular space size, the opening size, et cetera, et cetera. It'll also outline the type of products that are used as well. So all of these things, all of these holes above the wall can turn into a mess. How do you manage them? The company, the organization that owns the building or manages the building has to have some kind of a program for it. They're constant issues, these holes in walls, they got to be controlled through more means than just a Firestop contractor or a general contractor. It starts with the facility person, healthcare engineer, building engineer, doesn't matter. That person that manages the asset of the building has to manage the whole program, has to convince the corporate suite that owns the buildings that these barriers need to be maintained, and it's going to be a line item budget every year. Got to control the in-house and the outside contractors and make sure that they know what they have to do. The IT department, they have to be controlled to know what to do when they hit a barrier. So the hub for fire resistance and barrier management is the facility engineer. They answer to the Joint Commission, to the Center for Medicare and Medicaid Services, building official, fire marshal, the corporate suite, and most importantly, the answer to the staff that has to be protected in barriers and the patients that are in those buildings. A barrier management policy is something that could be developed by the engineer of the building. Doesn't matter whether they're ASHI member or not, or other type of association. That policy tool and that procedure is important to have in place to manage what goes on. Put it in contracts. AIA contracts to external contractors who are penetrating walls and floors, and then also those internal contracts with those that are going to be building new facility areas. Talk about the barriers in pre-construction meetings. Mark the walls and floors. This is required by the 2009 International Building Code now, that a certain stroke height and width of the barrier be described. And it's also going through the NFPA 101 now. We work together with International Firestop Council's Hilti and the FCIA member Hilti at the NFPA 101 meetings, along with UL and others on NFPA's Fire Protection Features Committee, to not just put up here that it's a fire or something, but to mark the barrier as it is. If it's a fire barrier, mark it as a fire barrier. If it's a smoke barrier, mark it as a smoke barrier. Why? Because once it's known what the barrier is, the penetrating item treatments are then defined. There should be violation consequences for those that poke holes. There should be ongoing management oversight. And most importantly, staff education and incentives for taking care of these barriers. How do you control the barrier? Documentation is critical. Whether it's on paper, paper with pictures on it glued to it, old sticky glue, if you will, to glue pictures to paper, or print out the picture out of your electronic camera, or an electronic file of some kind, whether it's a custom package that the facility has developed, or off-the-shelf packages from the manufacturers, or custom packages from various contractors throughout the country that have barrier management software systems. Several of them have developed these things, and they're quite good and extensive. Critical thing for the building owner and manager to remember is that you're not just managing fire stops. It's the whole barrier. Identify the barrier. Where is it on drawings? What is it constructed of? Concrete block, clay tile, gypsum wallboard, gypsum block. Finally, what are the penetrating items? Openings, the doors. Who manufactured them? What is the system for them? And track how they're installed and then maintained throughout the life cycle. Key things that are needed: life safety drawings, specifications. The existing conditions need to be documented. Ongoing survey records need to be done. Survey being different from the inspection. The survey would be a visual look at the wall and a declaration that it seems to be compliant. The only way to really know if the wall or floor is compliant is a destructive test. Cut it, saw through it, check the section of it to see if it complies with the life safety drawings and the systems requirements from the UL directory, and then document that so it's easily retrievable. There are systems for all these things: the barriers, the walls, the glazing, the doors, the dampers, and the fire stops. Then some kind of a repair procedure is needed. If you ask anyone in the trades about how they fix a fire resistance rated assembly, you get a million different answers. The right answer is what Nestor Sanchez delivers during his barrier management program, gypsum portion at the Barrier Management Symposium. If you take a look at these two designs, it talks about patching that would be conducted and made so it conforms to the Gypsum Association's recommendations. So if there's a hole between two studs, the Gypsum Association recommends cutting the wallboard over to the stud and framing the opening. Horizontal studs in between the two vertical studs would be installed, and then the wallboard installed to that, because the wallboard needs support behind it so that the patch doesn't get blown out during the hose stream portion of the fire test. So follow the Gypsum Association recommendations and patch it. Install a stud side to side amongst the vertical studs, metal or wood, doesn't matter, and then patch the drywall the way it's supposed to be patched. This is a very, very important patching recommendation. As far as the concrete block walls go, follow what the code says as far as achieving fire resistance. That's where the equivalent thicknesses of cementitious base materials are used to combine to come up with a fire resistance rating. So the hard part is, concrete block has holes in it. How are you going to wind up with the equivalent thickness to be able to have the right fire resistance? Frankly, cutting out a concrete block, installing a new one as it would have been in new construction is the best way to go. Best practice elements to include in a barrier management system. First thing is it has to have specifications, has to have surveys to assess the barrier and make sure it's in compliance, has to have action reminders, status of repairs in process, and then a way to get the records once they're stored somehow. One of the things that comes up frequently is barrier permits. Let's say a facility, this could be a healthcare facility, could be an office building, could be a dormitory, but let's say that somebody wants to install a penetrating item through the floor at 3T1 and run it through the fire barrier and above the fire doors to get to room 310 to put a new something. Fiber optic interduct, plastic pipe for plumbing or mechanical, sprinkler pipe, whatever it is. So first things first, they've penetrated a fire resistance rated horizontal assembly, so there needs to be something done here, and then penetrated a fire or a smoke barrier. If it's a smoke barrier, then we're talking about an L-rated Firestop system to meet the requirement of the L rating for the wall. The L rating for all fire stops is cumulatively 50 cubic feet per minute per 100 square feet of wall opening area. So we'd have to count up the penetrating items and see if this one puts us over the top. If it does, then we got to find a way to reroute penetrating items so that they're moved outside of that 10 by 10 area. Then there's a penetration where the pipe or penetrating item goes into 310. Doesn't matter whether this is a Firestop, a fire damper. Either way, the tested and listed system wins, and that's what we have to come up with to cover the code requirements. But there'd be a permit issued before that trade person could install this penetrating item across here. Maybe there's a sticker that the tradesperson puts on their ladder that gives them permission, a permit if you will, with an expiration date on it, showing that they can operate above the ceiling for a certain period of time with certain restrictions. If that person has a permit, the staff on that floor have been trained to know that to look for that permit for a lot of different reasons. It could be security reasons. It could also be for access reasons as well as authorization reasons. Security is huge due to the HIPAA requirements and privacy requirements by our governing organizations in this country. People like their privacy. They don't want to know that there are others that could be their neighbors, business acquaintances, etc., knowing that they're in a healthcare facility at any given time. So that privacy notice is huge. How does the person on the floor of the patient services control that? By knowing that the workers have gone through their screening processes through the facility manager downstairs or upstairs or wherever they're located. So the contractor outside or inside would have gone through that screening process, background check, security check, drug check, and then authorization by the hospital facility to work above that ceiling. And then finally, and most importantly, infection control authorization. There may be carts required to be with negative air to stop any germs that might be up above that ceiling tile from moving from place to place. Big important piece of it. So how do we track all this stuff? Software programs exist that would identify what's going to take place. It can track what Firestop permit number was given. This could say fire damper permit, fire door permit to work in that area. Dates of issue and then completion and when they're going to be active, so that when they're up on the floor with their permit, the nurses and other staff can know whether that person is authorized to be above the ceiling or not. No sticker on their card or ladder, they get reported downstairs, and to the facility people. And if they're reported offline, that facility engineer can come up to the floor and offer a pizza party to everyone for turning in that person that was not authorized to be above the ceiling. Really a very important piece. Then the scope of work is determined. Is it a wall or barrier? What fire rating is needed? Is there a penetrating item going through? And then what technician did what work? What system did they use to take care of it? And that system or that barrier permit might be something like you see here with the authorization on it. Then what system was used? The systems would be identified over here under the UL number. Is it compliant or not compliant? Could have a picture to it. And again, this could be a fire damper, fire door, any of it. I'm not going to cover time on this because these workflows, you can make them as complicated as you want. Critical thing is, from the fire resistance perspective, FCIA had a code proposal in to put labels on walls for fire stops to identify what the penetrating item was. This really completed, this code proposal, for instance, completes something very important in the circle of fire resistance. Fire damper manufacturers mark their dampers, tested the UL 555S. Fire door manufacturers have labels on the doors, labels on the frames. So the openings, and then the fire glazing manufacturer have marking on the fire-rated glazing. So everything's already marked. The only one that's not, from a penetration perspective, is the penetrating items and joints. It's not required to mark what system was used. Without knowing what system was used, UL, call it CAJ 1055. Without having that UL number, we don't know the manufacturer's of Firestop product, nor do we know the thickness of Firestop sealant, the type of mineral wool that might be behind it, the angular space allowed. We don't know any of that without knowing the system number. So what this does, if there's a marking on the wall, it sets up the rest of the operation such that the inspector, whether it's a survey person after the building's been built or a special inspector doing destructive testing after it's been installed, the inspector knows exactly what to look at. Go to the UL directory, pull out CHA, or in this case, WL, wall, a framed wall, under the UL directory, and look for WL 1055. It shows me a metal pipe. The inner space can be an inch, and then I can check it. Nobody has to go back and research what system was used after the fact by paging through and figuring out the manufacturer and the inner space. Huge, huge items. So important to have the documentation, important to have labels, important to have permits required with healthcare facility rules and infection control rules followed. The markings that are required currently by the International Building Code only include this, mark the barrier itself. Again, under the fire code, we're trying to get the barrier marked as to what it is: a smoke barrier, a fire partition, a smoke partition, and a firewall. Each of these are different things. Firewall would have an independence clause saying that each side of the assembly can collapse and one side of the assembly be completely there as well. Violations, 2 strikes and you're out for this barrier management permit, if you will, the policy tool, for both the in-house and the outside contractors. The in-house contractors, 2 strikes, you're not allowed to work above ceilings. Outside contractors, 2 strikes and you're not allowed to work in the facility, period. Incentives, give pizza parties to those that find the violators. Key thing is that it's got to be an ongoing management tool. Fire doors have to work. The fire-rated walls have to have the holes fixed, whether they're accidental or by workers. And in order to have fire resistance rated construction work, it's got to be continuous. The barrier, the wall, regardless of what type it is, the fire stops, the dampers, the doors, the glazing, all need to be systems. This fire effective compartmentation is in there for a reason. It's in there to work and protect people. Next question that came up from the audience here is an L rating required at a smoke barrier if the code does not require it? I'm assuming that the code does not require. The International Building Code, let me see if I can bring it up. Give me a second here. The International Building Code requires an L-rated fire stop for a smoke barrier. A smoke barrier is a 1-hour rated assembly. I'm not going to bring it up. So a smoke barrier is a 1-hour fire resistance rated assembly, continuously sealed. And it requires that the L rating be no more than 50 cubic feet per minute per 100 square feet of wall area. So yes, an L-rated fire stop is required in a smoke barrier. The code does require it. If the question is, this is a smoke partition, which is a zero-rated a zero fire-rated assembly, but with smoke resistance, the FCIA's position is yes, an L-rated fire stop is needed. And the reason is because the L rating is the only tested method and system that shows that it's smoke resistant. Otherwise, it's you and I and anyone else saying, I can use acoustical sealant or smoke and sound sealant. Yep, it'll work everywhere. There is a tested and listed system that's come up, that's been developed by the industry. UL standard 2079 and 1479 have an L rating in it. That L rating, the test, is done before the barrier is burned. So if you look at a wall and it's got 5/8 inch drywall on it, usually it's fastened about the same as fire resistance rated, whether it's rated or not. The way to approximate that smoke resistance is using an L-rated fire stop system that uses a fire stop product that's been used in that application. Great question. Thank you. So at this point, what I'd like to do is open up for questions. We've talked about the DIIM and looked across a lot of different industries. We know the continuity is needed. I'm going to post this presentation to fcia.org, right-hand side. Look for it tomorrow morning because I'll probably not get to it till late tonight. The Firestop Contractors International Association participates with the American Society for Healthcare Engineers and others. Our next symposium is November 17th in Bristol, Tennessee. Look for 5 more regional programs as well. We've done one in California at the Queen Mary. Great time and a great place. So at this point, what I'd like to do is take a couple of minutes and open up for questions. If you have a question, raise your hand or hit that question box or hit me on the private question and I'll answer it as well. I've got about 3 more minutes before I got to sign off, maybe 5, so we can take a couple of questions. First question that popped in, can fire-rated panic hardware have the dog open function? Good question. I can't say that I'm an expert in fire-rated hardware. All I know is that the force, the wedges and other things need to be appropriate. The fire resistance rated assembly has to be able to be activated by the smoke alarm detection system so that it works in conjunction with it if it's held open. Follow those systems. An answer just came in from one of my door friends that says no, electric latch retraction is needed. So question would be, awesome, it's good stuff. So can fire-rated panic hardware have the dog open function? Answer is no, just electric latch retraction. And then fire panic hardware does not have the dog feature, according to another expert on the line. Thanks everyone for hopping in. Great questions. Next statement is the door has to be listed for the use of the fire panic hardware. Absolutely correct. Great points, great question, and a thank you from the questioner as well. So there's questions up here. Fire-rated damper, what would you caulk them with to seal the perimeter if you can't use intumescent Firestop? That's a great question. The question is, what about fire-rated dampers? There are angles required around the perimeter of the fire-rated or the fire dampers. The damper itself is not rated. The damper, the angular space, the angles, the breakaway connection, and the wall are rated all together as one. It's a system. So there's no such thing as a fire damper rating. It's the whole system. The manufacturers of fire dampers, Ruskin and Greenhack, both have tested Firestop materials in the angular space where the angle goes, and instead of using sheet metal continuous angle, using clips and Firestop sealant on one side of the wall, and then a continuous angle on the other side of the wall. That's what's allowed. There's no such thing as, okay, we can just fire caulk this and be done. Sorry, no such thing. If you take a look at the presentation from the webinar in probably May or earlier in the year, I've got a section in the presentation on fire dampers and what is required. So take a look at that, you'll be able to see it. Another question, L rating, practically speaking, what's 50 cubic inch per 100 square foot really mean? Example. Okay, so let's say that a Firestop system was used around a conduit that goes through the wall. What the 50 cubic feet per minute per 100 square foot of wall area means is that if the single conduit penetration has an L rating of less than 1, that you could have 50 of those penetrating items in a 100 square foot wall area to be compliant with the building code, International Building Code. So that would mean that those buildings that were constructed under that version of the building code, that would be 2009 and better, or newer, that somebody has to make a 10 by 10 area, that'd be the general contractor or the building owner manager, count up the number of penetrating items, whether they're conduits, ducts, cable trays, whatever, and say, what's the cubic feet per minute of all of these L-rated fire stops in the smoke barrier per 100 square feet of wall area. If it exceeds the 50, then either the AHJ has to give a variance, which they can do, they have the right to do that, or the AHJ could say, nope, I want 50 cubic feet per minute per 100 square foot of area. Take those penetrating items and move them to an area outside that 100 square feet. I hope that gives you the visual that you were looking for. Thank you for the question. Further questions? Anyone else have questions? I see some hands up, so I'm just going to take a couple seconds and go through the hands and open up the microphone. I see Angela Temperio has her hand up. Angela, question? Okay, no microphone. Next question come in from the email. Is it allowed to take up responsibility of a healthcare institute, fire stopping and barrier management maintenance by a facility management company who is not from the fire stop industry? Good question. Thank you very much for asking that question. The building owner and manager has the right to hire whoever they want to do barrier management. If that building owner and manager feels that the company that they've hired can manage the barriers, the fire stops, the doors, et cetera, they can hire whoever they want. What we as FCIA would recommend is that the entity that the building owner manager hires has intimate experience in each of the disciplines that they're going to be managing, understands fire doors, understands fire dampers, understands fire stop systems. And in some cases, it may be multiple companies that service each. In some cases, it may be one company that services all of the above for the building owner and manager as a barrier management system contractor. Great question. Really appreciate you asking that from the Middle East. Thank you very much. Other questions? Waiting for them to hop in. I see some thank yous, and I'll post these slides, yes. So I'm going to go to the next hand that's up. There's a Charles Lee. Charles, you have your hand up. A question? No question there. Okay. Next person had already asked questions. Let's see, other hands up. Let's see, I'm not seeing more hands up and questions. Other hands up, Saifuddin, you had your hand up. Saifuddin Tahir in Dubai, do you have a question, or are you okay? I must not have the microphone on, that's okay. Other hand up, Simon or Simone Leclerc? Nope, not there either. William Kelly II, I opened up the microphone. Any questions? Very good. Okay, looks like the questions are done coming in. I have an appointment to get to, as do many of you as well. On behalf of the Firestop Contractors International Association Board of Directors and membership, really appreciate everyone hopping on the call to listen. Most importantly, I appreciate the questions that come in. I learn as much as you give when you do these questions. We have these presentations about 12 times a year as a resource to the industry to involve our membership that doesn't make it to conferences and involve other people that are not necessarily members. If you're not a member, we hope you join. If you're not a member and you're a building official, fire marshal, we've got a Friends of FCIA governmental employee kind of membership for 75 bucks. Special inspection agencies, 500 bucks ish. Contractors, 1,400, and we do prorate for the contractors and folks like that. Manufacturers aren't members, 3,300 gets you in the door. So that's my pitch. Thank you so much, and really appreciate everyone being on the call. So at this point, I'll wish everyone a great week. If you have questions, here's my email address, bill@fcia.org. Feel free to give me a call at 708-202-1108. In the overseas, don't forget the +1, and off we'll go. Thanks, everyone. Have a great week, and we'll look forward to talking on the next webinar from FCIA look for it in the announcements from Lindsay and our FCIA staff who do a great job of setting these up for me. Thanks, everyone. Have a great week. Look forward to seeing everyone at the next event. Thanks.